Test, test. 1, 2, 3. Singing to music you can't hear. Yeah. See how long the delay is. Welcome, 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 class. This is Computer Science 3, MI3. Introduction to Programming Languages. I will be your prof this semester. My name is Nicholas Moore. I think you should all know me, though, because I'm pretty sure that I taught all of you guys when you were in 1MD3, no? I think so. I think you guys are the class. You guys were the class that we had to... when we had to jump online at the beginning of the pandemic, you were the guys. This is the class. I'm pretty sure. Maybe somebody can correct me on that. I know that Mark was in that class. So, yes. Is the chat working? I'm not getting any chat. Ha. Yes, okay. So, you guys know what I look like. You know that I actually do exist. I'm not just some sort of, miscellaneous electrical, like an electrical disturbance in the fabric of the internet has conspired to produce my image. That's not the case. Yes. So, welcome. We got 43 viewers right now. That's good. Yeah. Yeah, how have you guys been? You know? How's the world? It's been a while. It's been a while, eh? Boy. I sometimes get nostalgic for teaching lectures in person again. I really do think it's kind of a miserable thing having to do all of these online. But, you know. So it goes. So it goes. Yeah. Yeah, I've improved the setup a little bit since the first the bit where I was just streaming from my laptop webcam. You know, I got myself a decent microphone, for instance. But yeah. Good old days. Oh yeah. Oh heck. You're also a TA. Doop-a-doop-doop. Now you're a moderator. Haha. I singled you out. Riddle is also a TA for 1MD3. Yeah. Yeah, nobody misses the commute, but, you know. I don't know. I feel like I'm slowly going crazy because I'm speaking to a brick wall for my entire life, you know? Thanks. I put some work into it, you know? If you guys are going to have to listen to me for like 50 plus hours this semester, you might as well do it with decent audio quality. That's what I think. But anyway. So, welcome to 1MI, or what? What am I talking about? 3MI3. Pardon me. As you might have noticed from the title card, I'm teaching like 3 courses this semester. First time teaching 3, so it's, yeah. You know, pretty good. So, there's me. You know me. Good old-fashioned me. My office hours are Thursdays 1:30 to 2:30. Hypothetically, that's going to be in person, so we'll see how that goes. I've been asked to have virtual office hours as well, so that seems correct, so I'll probably do that. Yeah. So, just okay for the audio? I rather liked the audio. So, you guys, having taken a course with me before, you're probably reasonably familiar with the manner in which I like to run things. Basically, the biggest difference versus 1MD3 is that we're not really going to be doing much in Jupyter, as I'm sure you haven't been doing much in Jupyter since 1MD3. We're going to be... This is more of a math course, really. It's kind of... It varies. You got this interesting thing that happens in the department where, like... Oh. Is the audio... Sometimes the audio craps out on me and I have to reset it. No, that's still good. Okay. Ta-da! Thank you. So, with this class, I was kind of in an interesting position with this class. I've never taught this class before. This is my first time. Yes, Brave. Brave is the best browser, just so you know. It's built on the Chrome base so that you can use like most Chrome extensions on it, but like cut out all the fluff so it's actually faster than Chrome. It's amazing. So let me talk about 3MI3. This course is programming languages, right? So there are basically two primary approaches that are taken to the offering of this course, depending on who's teaching it. This is like there are some courses in the department that are like it depends who's teaching it, and then there are some courses where it really depends who's teaching it. This is one of the courses where it really depends who's teaching it. And for better or for worse, yeah, free crypto. Woo! Crypto. For better or worse, you have me for a professor, and I have decided to operate this course in a way that makes sense to me, and, you know, because there's kind of a wide disparity with it. So if you take a look at the calendar description of this course, principles of definition and of reasoning about programming languages and domain-specific languages, use of semantics for interpretation and in program analyses for correctness, security, and efficiency. 3 lectures, 1 tutorial. So, those of you who had knowledge, like if you'd asked around about like how this course had been run previously when Mark Armstrong was running it, it was, in some sense, a survey course of various programming languages. The 4 that he covered in the most recent offering of this course were, I believe, Ruby, Prolog, Clojure, and Scala. However, it has been my observation that there's nothing in the description of this course, which, you know, hypothetically, the course is built from the description. There's nothing in the description of this course that would suggest that this is a survey course about programming languages. From this description, this is a course about the mathematics of programming language construction. So, given you know, that is the manner in which I am choosing to interpret this description. It also it seems to me like running this course as a survey course of programming languages, like, in some sense looks no further than the title of the course to try to determine the contents. And, like, I don't think that it would be bad to have a course which is a survey course of programming languages. I think that would be an excellent thing for the department to offer as an elective or something. It's just, it strikes me that that's not this course. So, basically, the way that this course is going to go, I've got the textbook, and we're going to be learning the stuff in the textbook. Obviously, I'm not going to be one of those profs that just reads the textbook to you. But the course is going to be based on the first 2 sections of Types in Programming Languages by Benjamin C. Pierce. Now, this course, this textbook is a little bit on the old side. It is from the year of our Lord 2002, which is getting pretty ancient as programming textbooks go. But it's not really about programming languages per se. It's about the mathematics underlying it, which has basically been decided since the 1950s. So, you know, the math itself has not, you know, it's had extensions since the 1950s, but we are in no way going to be able to bring us up from, you know, our current level of understanding all the way up into the, you know, the far reaches of that textbook or stuff beyond in just the course of the subsequent 13 weeks. So, we're going to be doing the first couple of sections. If you'd like the textbook, I recommend getting it. I'm not going to do any compulsory reading or anything. I'm not going to, like, require you to have the textbook to do questions or anything. It's an optional textbook. But bear in mind that everything that we're going to do in the course is going to follow reasonably closely from this text, so having the text is going to be more valuable to you than other courses in which the textbook is, you know, there but not required, such as for MD1, MD3, if you cast your brains back. So yeah, any questions so far? Hopefully not too many questions. Yeah. So, while I'm waiting for those questions to come in, let's talk about the tutorials. So, there are 3 tutorials which have been scheduled by the registrar. Each one of those is a physical tutorial. Each one of those will be occurring in MeetSpace. We will be having one virtual tutorial section. That will be happening in cyberspace. And we will be... we have a poll up on Piazza right now to determine what the most preferred time for that tutorial is. So if you... hopefully the link works. Doesn't look like it's... That looks like a very strange link. But hopefully you all remember Piazza. I'll get the link fixed. Or if you... I think if you just copy and paste that as a URL, then you'll be fine. But yeah, so let's see. Yep, there we go. If you take a look at this poll, please fill out the poll and indicate the times that you would be available. I see one person has... Oh, nope, 3 people. So right now we're going Friday at 5:30 is the winner so far of the 3 people who have filled out the survey. So, you know, there we go. But yeah, so the cyber tutorial will be recorded as well. So if you can't make it to the session itself, you'll be able to pick it up afterwards. So there you go. Do tutorials count for marks? No, but they are otherwise useful. Generally speaking, in my classes, I like to have the tutorials cover different things that are still useful than the lectures covered. So the first tutorial, for example, will be on the subject of LaTeX documents and producing LaTeX formulas and that sort of thing, which is a skill that will become in handy when it comes time for you to do assignment 1, which is also up on Avenue right now. You may notice that there are not many course resources available as of yet. That's because I am in the process of generating them. I will be generating the course content for this course concurrently with its execution. So, you know, I will upload things as I finish them. And, you know, they're not necessarily going to be, like, just because I upload something doesn't mean, like, it's due in a week from me uploading it. It's just I finished it, so I put it up because I don't want to have to remember to put it up later, sort of thing. But anyway, yeah. So we're not going to use GitHub. We're going to use the department's GitLab. So you may not have known this, but the department has a GitLab server, gitlab.cast.mcmaster.ca. You can create your own repositories here. There will be instructions on how to do all of this. This is what we're going to use for the submission of assignments that have a lot of code involved. So, yeah, this will be good. Will the virtual tutorial be recorded and posted? Yes! Yes, it will. Yeah. Good. So we'll be using GitLab for some of them. Others will just do regular submission through Avenue. The assignment will say on it the means by which it is intended to be submitted. Good. We've got 3 TAs this semester. We've got Habib, we've got Pasara, and we've got Nina. So yeah. Okay. So, Andrew, you've been having issues getting into it, and you couldn't get in touch with the department head to fix it. Well, if you're trying to address that concern to the department head, that is the wrong person to address it to. The person that you'll want to address that to is Derek, or John, or Sebastian, who are the IT people. The department head doesn't do server management stuff. That doesn't make any sense. Which programming language will we use? Primarily Haskell. So that's actually one of the things. So historically speaking, again, historically speaking, there was a much bigger divide between the ways that this course was offered. Like 20 years ago, according to Dr. Sekerinsky, you would cover N programming languages in N+1 weeks. And in other ways, you would learn a functional language in this course in order to be able to do the math in this course. You can find their information on the department's webpage under staff. They are staff, not professors. Andrew. So, primarily Haskell. Sort of in the spirit of the old way of doing things, I'm thinking that perhaps towards the end of the course we could bring in one or two little examples having to do with type theory. Rust, maybe we'll do Rust, and we might do WebAssembly as well, because they have interesting applications of type theory in them. We're not going to learn, for example, Ruby just to learn Ruby. The course is being reorganized so that everything we do is in support of the math that we're going to be learning in the course. So we're trying a more unified approach. Like, the problem I found with the way that it had been set up previously is you spend so much time teaching all of these languages that you don't have any time left to teach the actual math. And given that the math is the thing that actually appears in the course, in the calendar description, you know, that hypothetically should be the focus of the course. But anyway, so you need, as prerequisites, CompSci 2CO3, which I think is a C course, maybe not, 2LC3 or 2DM3. So that is your discrete math course. You will definitely need that as a prerequisite. 2AC3 or 2FA3, not sure what those are, and 2ME3, also not sure what those are. Although that was the one that most people wanted exemptions for not having that credit in order to still take this course. So, in general, this is... Wait, is this an old version? I think this is an old version. Give me 2 seconds, I'm going to update this. I think I updated it without updating it, so to speak. Boop. Okay. So, the traditional proofs, cool. Discrete math 2, software development. Okay, so if you guys have done some proof work, that will serve you well in this course. So I haven't quite decided yet, because things are still reasonably, how do you want to say? The bread hasn't risen yet. You know, the dough is still rising on this course. I haven't nailed down absolutely everything with respect to the course policies, you know, because this is the first time I'm running it. So I might end up collapsing the project component into the assignment component, and then taking some of that weight and applying it to the test and the exam. Previously, this course had no test or exam. It was just a project course. But, you know, again, this is a math course, and math tests make sense. So, yeah, basically. Assignments currently at 30%. Projects currently at 30%. Test at 15%. Exam at 25%. We'll see. We'll see about that. Yeah. Again, I haven't quite decided about that yet, but we'll see. So, course timeline. This is basically the plan is to have weekly assignments, short weekly assignments, in the style of the assignment that's still up there right now, and perhaps a test somewhere in the first week of November, maybe the last week of October. We'll see. All of this information is subject to change without notice and notice without change. What are the projects? Well, that's the thing, is I don't actually have them typed up yet. But in general, I'll give you a general overview. So, in this textbook, I said we're not going to cover all kinds of different programming languages, but that's not entirely true, because over the course of the material in this textbook, we will be discussing 4 programming languages, which are all quite small. They're the type of programming language that you would be able to implement inside of another programming language, like, for example, Haskell. So there's untyped expression language, lambda calculus, untyped, a typed expression language, and then a typed lambda calculus. So my theory going into this course is that it would be reasonable for these projects to be constituted of, okay, we're going to talk about this in class, and now you go implement it. That was kind of my idea for the project. Again, we'll see if that ends up coming to pass. I might, in theory, I might take the project material and make it into assignments. We'll see. Is there a link to the 3MI3 GitLab? There isn't a 3MI3 GitLab. There is the department's GitLab. You will make your own repository and then make us collaborators on it so that we can download and, so that we have access to your GitLab. That's how that's going to work. Cool. 3rd lecture today. My voice is starting to go. So, as noted previously, the textbook is Pierce Types and Programming Languages from the MIT Press. It is a beautiful textbook. It is typeset in LaTeX, which just makes my heart flutter. So, it's not required, but this is considered the classic text for the material that we're going to be covering. This is a classic text in the same way that Algorithms, Introduction to Algorithms 3rd edition is the classic text for an algorithms course. This is, by the time you get to part 3, considered graduate level material. So this is one of these courses that, you can sort of peel the first few sections off of it, turn it into an undergraduate course. But if you wanted to go into any more depth, you would be studying this at a graduate level. So, yes, that's all true. So, for getting assistance, we've got the Piazza thing set up. Has anybody filled out? Lots of people have filled out the poll. So far, Thursday at 10:30 is winning. And nobody wants Thursday at 9:30. Okay. All right. So yeah, Piazza. You guys have had B with Piazza before, so I'm assuming you know how it works and what it's for. Always, you can email either myself or your tutorial to TA or anything like that if you want to talk to a person. Just keep in mind that this semester is a bit of a busy one for me. I'm, in one way or another, in charge of about 500 people, which equates to, I believe, something on the order of $1.65 million worth of tuition money. So, if I don't get back to you by email immediately, it's because I'm very busy. But the TAs are less busy, hypothetically, so should be able to answer your questions more quickly. Academic integrity. I'm assuming you all know all of this stuff. We're probably going to be using MOS for a certain amount of plagiarism detection, particularly applying this to things that actually involve code. And, then we've got all the rest of the boilerplate items. Are there any other, does anybody have any questions about the information presented thus far? This is basically a class in applications of formal methods to programming languages. It's going to be an interesting class for me because this course is reasonably close to my actual doctoral research. So, you guys will know that I've been saying for a long time that I should just hurry up and graduate already. But yeah, so my particular area of research is applications of formal methods to hardware description languages, which are a domain-specific language and therefore fall under the category of things with grammar and things with semantics, so you can hypothetically write tools for them that allow you to, do interesting things. In my particular case, I take hardware descriptions in this language, and then port them or translate them over to Prototype Verification System, PVS, which is a theorem prover and is based in higher order logic. So that's my background. Although it might not seem like it, I actually have a pretty decent theoretical basis in the material that I'm teaching this time for a change. So, I'll try to make sure that this course is maximally interesting and useful for you. Does your repository that you need to make need to be on GitLab, or would GitHub work as well? So I would vastly prefer GitLab. In fact, I'm going to require GitLab for a very simple reason. In GitLab, when you invite someone to a repository, that invitation does not expire unless you make it expire, whereas in GitLab in GitHub it expires after a week. So we were having I tried using GitHub for submission last semester for the first time for 1xC3, and it was kind of unfortunately I trapped one of my TAs in this fractal spreadsheet nightmare of permissions. So this, using GitLab, hypothetically that'll clean up the permissions, and that will make everything much easier to do for us. So yeah, GitLab, please. Did something similar when you were with Intel. Worked with OneSpin. Oh, I didn't. What's OneSpin? Intel. Advanced verification platform. Yeah. Yeah, this sounds like it would actually work, though, as opposed to my thesis research, which doesn't really. Well, it's like try building something like this from scratch just by yourself, Oh, partnered with Siemens, eh? Very cool. Yeah, the Intel guys are pretty big into hardware verification for obvious reasons. They got burned pretty bad on the floating point. The floating point error with the Pentium processors in the 90s. They kind of learned their lesson. Because you can always patch software, but you can't patch hardware. But yeah, that's cool. Yeah, so this class should be pretty easy for you. But yeah, cool. Right. So let's get on with it. Will you keep using YouTube, or will we move to Teams? We will continue to use YouTube, and Teams will be for the tutorials. Yeah. Good. If A1 is giving you flashbacks, that's good, because it's supposed to be a review exercise. Yeah, it's definitely going to be YouTube. I can maintain a much higher quality stream if I'm using YouTube than I can with Microsoft. Like, Microsoft, you can buy a fancy mic like this, but it doesn't even make a difference because it's compressed all to hell, right? You know, like, ugh. I hate Teams for lectures. I hate Teams for lectures. Going to be use YouTube. If YouTube breaks, we'll jump to MS Teams, and I'll post an announcement about it and everything. But no, YouTube. I will post the links to the YouTube lectures in the announcement feed. Because they're unlisted videos, because I've had problems with trolls in the past. So, yeah. Will the lectures be recorded? Yes, they are currently being recorded. So you will be able to view the lecture content as soon as I put it public. I just remembered that I forgot to put my earlier I forgot to put the earlier ones public, but I'll do that. Man, I'm out of practice. I've only been not teaching for like a month, but I'm still out of practice. It's funny. So, yeah. So why don't we start talking about the course and stuff? Why is Teams so bad? Because it's written by Microsoft. No, but seriously, because it's written by Microsoft. Yeah, it's... No. Teams, no. It's because it's basic... Like, okay, I've never had this confirmed, but this is what I think, right? I think that the group call chat feature in Teams is Skype. I think that they put Skype in it. I'm pretty sure, because the call, like the call tone, sounds Skypey to me. It just sounds very Skype, you know? But anyway, yeah. Will there be subtitles for lecture videos? Only automatically generated ones, but yeah, I think they're configured for automatic subtitle generation. Pretty sure. Yeah. Ah, but Microsoft didn't write Minecraft. They just bought it. I remember when Minecraft was an was not owned by Microsoft. Oh man. Should there be any project created by instructor on student's GitLab? No, I didn't. No. Nope. Yeah. You know. Microsoft. They're always listening. They're always listening. No, it's Google that's always listening, and the NSA is always listening. Through these bloody things. But no, I installed Mint. Like, I'm very pleased with this setup, because, like, I'm running, like, I'm not even dual booting anymore. I have walked away from Microsoft. I am a pure Linux guy now. Yep, the Teams is built by the same people from Skype. That makes sense. That makes sense. So, all right. Anyway, enough nonsense. Let's talk about some more nonsense, by which I mean programming languages. Yeah. So, what is even the point of view? They were just grandfathered in some old software for Teams video call. Yes. I swear to God. I swear to God. Oh yeah, Alexa. Yeah. My God. I don't have an Alexa. Or whatever the Google version is or anything like that. I'm not quite to the level of putting my phone in the microwave, but, you know. Hey, if you've got nothing to hide, you've got nothing... They can have as much access to your personal information as you want, right? Anyway. So, what is even the point of this course? We are going to study how programming languages can be constructed using the formal mathematical tools you learned last year in such courses as Comp Sci 2LC3 and apparently 2FA3. We will use formal methods to define and reason about programming languages. Using these tools, we will construct a number of small programming languages and reason about their correctness. Type theory will be a major topic of this course, as will lambda calculus. So, let me just speak very briefly about some of these things. So I already told you about the 4 small languages that we're going to talk about. We'll also be talking about extensions to those languages. So, you know, when we talk about typed expressions, we're probably also going to talk about structs and stuff like that. Like, in general, for the expression language type stuff, you should be thinking like somewhere in the vicinity of C, and for lambda calculus, you should be thinking of like a very small subset of Haskell. So lambda calculus, it's kind of interesting. Lambda calculus is an alternative computational mechanism to the Turing machine on which everything is based. It's kind of interesting. At that time, there were a lot of different theories, a lot of different mathematical theories about what a computer would look like mathematically. It just so happened that Turing machines were the most completely and directly implementable version that, you know, they could get a prototype working for, you know, in time to beat the Nazis. So that's, you know, and once the Turing machine sort of saw that level of success, it was easy for it to see subsequent levels of success. But one of the major competitors to the Turing machine was lambda calculus, which was developed by a man by the name of Alonzo Church, which is a fantastic name. Church and Turing actually worked together sometimes. I believe, I'm not sure what it is, but I know of the existence of the so-called Church-Turing thesis, although that might not have been written by Church and Turing now that I think about it, because science is weird with its naming sometimes. But, yeah, lambda calculus it's based on the idea, like, if you've used lambdas in Haskell, if you know how to use a lambda in Haskell, then you pretty much know how a lambda expression works. And that's basically lambda calculus is lambda expressions nested inside of each other to infinity and beyond. So, lambda calculus. Don't let the word calculus throw you off. I know a lot of you went into computer science to avoid calculus, but calculus just means a method of calculating. So, formal methods then. In computer science, we use formal methods to reason about the correctness of software and hardware. Advanced mathematics are employed to attempt to demonstrate the consistency of a program with implicit or explicit specifications or requirements. See Comp Sci 3RA3. I think are you guys taking 3RA3 now, or is that next semester? Quick question. Yeah. Yeah, Python's got lambdas too. Everybody has lambdas these days. But that doesn't mean that it's right. Haskell is the best lambda language. Anyway. So, generally speaking, there are lots and lots of different formal languages. B and CS to avoid calculus. True story. See? I know your mind. I know your mind. Next semester? Yeah, okay. So this will make more, you'll be able to plug more bits and pieces into this knowledge once you've taken that course. So, you've got two major categories, so-called full-strength formal methods and lightweight formal methods. Generally speaking, lightweight formal methods are, they're the ones that are more applicable, generally speaking, because they're the ones, they're much more amenable to automation because they require less thinking, if that makes sense. So, take, for example, Hoare logic, right? When you write a precondition and a postcondition, in order to demonstrate the consistency, you need to come up with an invariant. And in order to come up with the invariant, it requires a human brain. It requires a little bit of creativity, which makes it less useful for computers. Because we can't teach computers... until we figure out how to give computers souls, human beings are still going to be the ones with the imagination. So, less applicable. So, really, a lot of formal methods research and application goes on in the lightweight formal methods category, including, actually, my own thesis research is in this guy. So, full strength, you have things like Hoare logic, algebraic specification languages, modal logics, and denotational semantics. We'll talk about a certain amount of this stuff, that type of stuff, over the course of this course. Lightweight formal methods include things like model checkers, satisfiability modulo theory solvers, SAT solvers or SMT solvers. Actually, if you're looking for an interesting thing to do research in at a graduate level, applications of SMT solving is very cool. For example, for one part of my thesis research, I had to essentially verify that a collection of if statements were mutually exclusive, based on what the conditions were, right? So what you do is I actually, in Haskell, I used the SBV library to set up a satisfiability problem regarding those guards, and the computer checks, it solves whether or not your condition is satisfiable, right? So, basically, if there exists one, arrangement of variables that satisfies every one of those conditions, then, they are not mutually exclusive, right? So you can set things up logically like that. But SMT solvers are really cool. Runtime monitoring and type systems. Type systems, again, are going to be a major subject in this course. So let's talk about type systems. What is a type system exactly? A type system is a tractable syntactic method for proving the absence of certain program behaviors by classifying phrases according to the kinds of values they compute, or the types of values they compute, if you will. Fnr, fnr, fnr. So, tractability. In computer science, a problem is intractable if it can be solved in theory but not in practice. For example, the state explosion problem is a source of intractability. Oh, my goodness. Well, 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 we have some disagreement about when 3RA3 actually is. You guys should take a look at your schedules, I think. Be careful, because for one of my classes this semester, Mosaic, forgot to tell me about an entire tutorial section, and, I only just found out about it, yesterday, because a student was like, hey, my tutorial isn't in the syllabus. And I'm like, oh, it should exist if your claim is correct. And then I verified the claim, and it's like, shoot. Ugh. But we got another TA. So, whenever you're dealing with Mosaic, assume that problems can happen. So, anyway. Have you guys heard... Let me do a poll here. Have you heard of the state explosion problem? So, type systems are also a syntactic tool. That is, we are analyzing the program's grammatical structure. We are, in general, this classifies it as a pre-compiler step, not a post-compiler step. Oh my goodness, 90% of you haven't heard of the state explosion problem. Okay, that sorts the last 2 minutes of this class. Using type systems, we can demonstrate the absence of certain bad behaviors, but not their presence. So type systems are necessarily conservative. So, all right. The state explosion problem. In 2 minutes. Here we go. Take an integer, right? If you have an 8-bit integer, there are 256 possible values of that integer. For every bit that you add, you double that, right? Exhaustive checking over integers is technically possible, it's theoretically possible, but infeasible practically. Because to exhaustively check anything of any size, for example, to check all of the possible tweets, for example, and a tweet is limited to 128 or 140 characters. In order to check every possible tweet, you would basically need 1 second for every atom in the universe. Well, no, top down. So, if you take the universe, you take every atom in the universe, put another universe inside of it, put a universe inside of the atoms of every inside every atom of that universe, and then repeat that process I think 5 or 6 or 7 times, and you had at the end 1 number for each of those. That's all of the test cases that you have to pick. All of the test cases you have to solve. So, it's impossible to actually do that because you know, even if you bent every computer in the world to processing test cases for all of these different cases, you would still need longer than the eventual heat death of the universe in order to actually process all of those test cases. This is generally what's known as the state explosion problem. The problem, more clearly stated, is as the state of a system grows, the number of cases to check exhaustively grows exponentially on that, and soon outpaces your ability to check test cases. This is why when we test things, we don't generally test 1, 2, 3, 4, 5, 6, 7, 8, 9. You test a range, you do coverage testing, you do all that kind of stuff to avoid having to do exhaustive testing because you can't, because it's impossible. But it's not theoretically impossible. In theory, if you had a computer inside of a time bubble that could run for, quintillion years or something like that, in theory, you could process all of the test cases. But that does not mean that the problem is tractable. So there you go. You now know what the state explosion problem is. So, yes. Anyway. Right, it's an elective. Yeah, cool. So, yeah, anyway. I think that's everything for today. Thank you very much for attending today's lecture, and I realize it's kind of a little bit loose at the moment, but things will firm up as we progress with the course. So, yeah, stay tuned. Take her easy. All that good stuff. If I'm looking over here, it's because I've got the streaming software open here so that I don't have to show you on screen anymore like I used to have to do. So, yeah. If I'm looking off here, that's particularly why. I'm not trying to avoid eye contact. Cool. All right. See you folks on, what is it? Thursday, I think. Let me see. Is it Thursday? No, tomorrow. Tomorrow and then Friday. Okay, cool. Take her easy, folks. Stay frosty, my friends.